What is up, guys? Welcome back to science class. Teachers, please pause here and allow students to attempt to answer this question. All right. I'm certain you guys might have been a little bit confused about this because this is new information. But in case you wanted to try it out on your own, I wanted to give you the chance. Which of these circuits is a complete circuit? The answer is A, C, and D. I know this because all of these circuits include a battery and wires that connect to the battery. B cannot be a complete circuit because it does not have a battery, which is where the electricity comes from. All right, so today I'm super excited because we are starting a new unit. This is Unit 4, Electrical and Light Energy. We will be focusing specifically on electrical and light energy for this unit. Your objective today is students will be able to classify and describe that a series circuit has one path and electricity travels where there is a complete path. If this doesn't make sense to you yet, buckle up because here is what we will learn today. If you would like to pause here to read the key points, teachers, feel free to do so. All right, so here's our new information, guys. This is a series circuit. Electrical energy is produced when charged particles move from one place to another. A constant flow of charged particles is called an electrical current. You can see the electrical current happening here with these little E's. Those are the charged particles that are flowing through this electrical circuit. And a circuit is just a word for a path that electricity flows along. It starts at the power source, which is a battery, and it flows through these wires to a light bulb or another object that produces either light, sound, or heat. Then it will flow back to the other side of the battery. The important thing to note is that wires have to be connected to both sides of the battery for the electrical current to flow. So if these orange wires are only connected to one side of the battery, then the electricity will not flow. It has to be connected to both the positive and the negative sides of the battery for it to work. Students, I want you to take out your science journal here. Teachers, you can pause to allow students time to do this, but they should be writing down that wires must be connected to both sides of the battery for the electrical current to flow. You have to remember this. Teachers, give students time to write this down. All right, now we're going to talk about the difference between a closed circuit and an open circuit. All you have to do is remember it like this. If there is no gap and everything is closed, then it is a closed circuit. And closed circuits allow electricity to flow because there are no gaps. So you can see here in this closed circuit that the wires are connected to the positive and the negative sides of the battery. So the electricity is able to flow all the way around the circuit. Now, an open circuit is where there is an open gap. You can see this space here is open. The electricity cannot flow through these wires because they're not connected. There's a break there. Electricity cannot just hop through the air, okay? So if there is ever an open space in a circuit, then the electricity cannot pass. Let me see if I can get this little pencil to demonstrate it for you. So what you guys are going to be doing with circuits is you're going to be drawing the path of the electrical current like this. You start at one side of the battery, follow along the wires to trace the circuit. Now, I had to stop here because the wires are not connected. So you can see from my electrical current that I drew, sorry about that, You can see from the electrical current that I drew that the current is not connected to both sides of the battery because it didn't reach this side because of the open space. That is why the electricity is not flowing to this light bulb, because the wires are not connected to both sides. The current cannot reach the positive side of the battery because of this break. Teachers, please let students also write this in their journal. They can even draw a picture and use a marker or a colored pencil or a crayon to draw the flow of the electrical current, just like I did. All right, here's a little GIF of an electrical current. You can see that when it is open here, the electricity does not flow. We'll wait and watch it again. You need a battery. This is called a switch and a light bulb. When the switch is open, the electricity does not flow, but once that switch closes, the electricity can start to pass. Let's watch that one more time. See how it's open right now? But as soon as it closes, the electricity starts to flow. All right, now we're going to get into some note taking. Here, teachers, you will need to pause on each slide and allow students to copy the word here and the definition here into their science journal. The first word is an electric current. An electric current is the flow of electricity, and it can produce light, heat, or this should say sound. Sorry about that, guys. I made a small error. This should say sound. Oh, it won't let me draw. Boop, 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 boop. Sound. An electrical current can produce light, heat, or sound. Now, what is an electrical circuit? Well, an electrical circuit is the path through which the electrical current flows. Remember that I said when there is an open gap, the electricity cannot pass. Make sure you're writing these definitions in your journal. Teachers, be sure to pause on each of these vocabulary slides. Next, we have a conductor, which you guys already know. A conductor is a material that allows the flow of electricity. Remember that a conductor will let the electricity pass through. Teachers, you can also now ask students to give you some examples of conductors. If, whenever they were giving examples, they said anything that is metal, they are correct. Metal is the best conductor of electricity. Now we have another word we're already familiar with, an insulator. An insulator is a material through which the electric current does not easily flow. So insulators will stop the electricity from flowing. So here, even though the wires are connected to both sides of the battery, this insulator is stopping the electricity flow right here. That is why this light bulb is not able to light up. Teachers, you may ask students to give you some examples of insulators. All right, we already talked about this as well. A closed circuit is an electrical circuit in which the current flows through an uninterrupted path. That means there's nothing stopping the electricity from flowing. So it is able to light up a light bulb or produce heat or sound, depending on what object you have here. And on the other hand, an open circuit is an electrical current in which the current flow is interrupted by either a broken wire or an open switch. So here we have a broken wire that is stopping the electricity from flowing. And here we have an open switch. Because this switch is open, there is a gap in the circuit, so the electricity cannot pass. All right, now we're going to talk about the different parts of a circuit. Every circuit has at least 3 things. You always need a battery, the wires, and then some kind of object that will tell you if the electricity is flowing. Most of the time, you will see either a light bulb that will produce light or a buzzer that will produce sound. Now, circuits will not work without a battery because the battery is the electrical energy source. This is where the electricity comes from. If there's no battery, then there's no electricity to flow. A circuit will not work if there's not a battery. Also, remember that wires must be connected to both sides of the battery for electricity to flow. If the wire is only connected to one side of the battery, the electricity will not flow. It has to be all the way connected to both sides. Teachers have students write this in their journal. As I said earlier, a light bulb is used as the electricity receiver. It receives the electrical energy and converts it into light energy. We also need wires, and the wires help the electricity flow from the battery through the wires to the light bulb. Something to remember is that the actual wire is a conductor, but the plastic that surrounds the wire is an insulator. That's why you can touch the wire and you won't get shocked from the electricity. Some circuits will also have a switch, and a switch can be used to turn the circuit on and off. If the switch is closed, the electricity will pass. If the switch is open, it creates an open circuit, so the electricity cannot pass. Now, this is super important. Make sure you write this down in your journal with a lot of exclamation points. If there is a break in a series circuit, all of the lights will turn off. Every single light, even if there's just one break, all of the lights will turn off. Here is an example of a series circuit that you might be familiar with. Christmas lights are series circuits. So my question to you is, what will happen to the lights if there is a break in the circuit? If one of these wires opens up or breaks, what's going to happen to all of the lights? If you said all of the lights will turn off, you are correct. Teachers, pause here and ask students to tell you which circuit is closed and how do you know? This circuit is closed because there is no breaks in the wires and you can see the electricity flowing. Now, which circuit is open and how do you know? Circuit 2 is open because there is a break in the wire here. So the electricity, if I draw the path, the electricity will not be able to pass through this break. It can't pass here, so this circuit is open. Now, one more question. What happens if there is no battery in a circuit? The answer is the electricity will not flow because without a battery, there isn't any electricity. The battery is where the electricity comes from. You can feel free to pause and write this down, students. All right, here's another question. I'm about to run out of time, so I'm going to go quickly through these. Teachers, just pause and ask students what they think. What will happen to the lights if you cut the series circuit here? The correct answer is all of the lights will turn off. If the wire is broken anywhere in a series circuit, all of the lights will turn off. Teachers, pause and ask students what will happen to the lights if it's cut here. And what will happen to the lights if it is cut here. All right, that's it, guys. Please make sure that you go to the Teams channel and complete your practice and exit ticket. Do it now. If you don't do it, you get a 0. I love you, but seriously, do it.